This screencast is about the multiple linear regression measures of variation and about a hypothesis test for the overall usefulness of a multiple linear regression model. The quantities SST, SSR, and SSE are the same as in simple linear regression. SST measures the squared error when the mean of the y data, y bar, is used to estimate the data set yi values. SSR measures the squared error explained when the ith fitted value is used to estimate the yi value in the data set. SSE is a squared error that remains unexplained when the ith fitted value is used to estimate the yi value in the data set. It's a general result that SST equals SSR plus SSE. And in fact, the same equality holds for the associated degrees of freedom. n-1 associated with SST equals k associated with SSR plus n minus the quantity k plus 1 associated with SSE. The coefficient of determination is again the explained error divided by the total error. R squared adjusted is this function of the coefficient of determination. R squared adjusted expresses the percent of total squared variation explained by the predictor variables after adjusting for the number of predictor variables in the regression, that's k, and the number of data points, n. The mean square for regression is SSR divided by its degrees of freedom, k, the number of independent variables in the multiple linear regression. The residual variance, or mean square error, is SSE divided by its degrees of freedom, n minus the quantity k plus 1. The residual standard deviation is the square root of the residual variance, or the square root of MSE. Here's a result. When the model assumptions hold, then the mean square for regression divided by the mean square error is distributed with an F distribution with k degrees of freedom for the numerator and n minus the quantity k plus 1 degrees of freedom for the denominator. I've moved to the next page. On this page, a hypothesis test for overall model usefulness is presented. The null hypothesis says all of the coefficients of the x variables in the model are 0. That is, when x data is entered into the model, it will all be multiplied by 0 and the y estimate won't change. That is, the model is not useful. The alternative hypothesis says at least one of the betas is different from 0. Thus, if x data is entered, there will be some change in y, and the model is useful. In the second step, we limit the probability of incorrectly deciding that the model is useful to the significance level of the test, alpha. From the previous result, if the model assumptions hold, then MSR over MSE is distributed with an F distribution with k degrees of freedom for the numerator and n minus the quantity k plus 1 degrees of freedom for the denominator. This shaded area on this F distribution graph represents the p-value. In step 4, Excel toolpack is used to obtain the p-value for this F test. The p-value appears on the ANOVA table. In step 5, we make our decision. As always, we reject H0 if and only if the p-value turns out to be less than or equal to the significance level of the test. I've moved to the next page. This data indicates the relationship between sales and radio advertising expenditure and newspaper advertising expenditure. Sales will be our dependent variable. Each variable is expressed in terms of thousands of dollars. There are 22 data points, and there is no time series component in the data collection. The goal is to select the best model to estimate sales based on the two independent variables, radio and newspaper advertising expenditures. Possible models include the simple linear regression model that uses only newspaper to estimate sales, the simple linear regression model that uses only radio to estimate sales, and the multiple linear regression model that uses both newspaper and radio to estimate sales. We'll later see that there are other possible models. A good model would have a relatively large adjusted R-squared and would satisfy the model assumptions. We'll discuss checking the model assumptions in section 14.3. On the top of the next page, the regression statistics tables for the two simple linear regression models appears. When only newspaper is used to predict sales, the adjusted R-squared is 21%. And a standard error of approximately $306,000 is made. When only radio advertising is used to predict sales, the adjusted R-squared jumps up to 46%, and a standard error of $254,000 approximately is made. Next, we'll fit the multiple linear regression model that uses both radio advertising expenditures and newspaper advertising expenditures to predict sales. Here is the regression drop-down box that needs to be completed. The difference from simple linear regression is in the entering the X range, C1:D23. The entries for the X variables appear in cell C1 through D23. The independent variables in a multiple linear regression need to be contiguous, that is, next to each other. The variable on the left will always enter as the first independent variable, and the variable on the right will enter as the second. Let me open an Excel spreadsheet and go through this. I'll begin by copying the data. I had to resize the screen capture, so I'm not entirely sure how that'll appear. Let me paste in the data. I also formulated some of these columns. Let's go through the two variable regression. Data analysis. Looking for regression. Here we are. Okay. Drop-down box. The input variable is sales. The X range from C1 down to C23 and then over to D23. So we've got those two columns. Radials on the left. We've got labels in the first row. Let's keep the data on this page. Output range. Got to click in here. Put it in F1. And let's get the residual output. Okay. Here's the summary output for the regression. We have an adjusted R squared of, about 79% in a typical error of about $159,000. These results are better than the simple linear regression results. Whenever we compare models with differing numbers of independent variables, we always use the adjusted R squared rather than the R squared. For the estimated regression equation, here is the B0, the B1, and the B2. Let's return to the Module 5 notes. Here is the Excel output we were just looking at to a different number of decimal places, at least in some of the entries, and without the fitted value and residual value table at the bottom. On the next several pages, you are asked to go through a sequence of U-try problems. In the blue area, you are asked to go through all 5 steps of the hypothesis test for overall model usefulness. There is a U-try problem at the end. This will complete this screencast.